Today we're going to learn about statistics and really introduce some of the basic definitions. So we're going to start with section 1.1, the first section in our textbook. And again, chapter 1 is really about definitions and really getting used to the lingo that we're going to use in statistics. So let's introduce that now. What you see in front of you are the lecture notes for section 1.1. If you're able to print these at home, then that's great. You can go ahead and print them and follow along with me and fill in the lecture notes as I do. If you're not able to print them, that's okay though. So what you could do as one option, if you have a device that allows you to write on documents, some sort of tablet or even touchscreen laptops and things like that, you can go ahead and just save that file and write right on top of it on your device. Or if you're not able to do that, that's okay too. You can review the work and just kind of save it and review it as you need it, and then just take your own notes in a notebook or in a binder or something like that. Just make sure to take detailed notes if you do that, fill in all the information, and then you can kind of refer back to the digital lecture notes and your handwritten notes together to go through the material. These examples are going to be taken from section 1.1 in our text, so you do have an overall citation here. I'm not going to cite every single problem in the text, so please refer back to your text for full details and information. A lot of the examples we do are actually real world examples, so you'll see those citations in the text as well. So I just kind of have the overall text, but please refer to your actual textbook for further citations and so on. All right, let's get started. So we have two basic definitions to start with: data and, of course, statistics. So data consists of information coming from observations, count, measurements, or responses. For instance, responses to surveys or something like that. The word data is actually plural. So if you see the word datum, which is spelled like this, that is the singular. Usually we always have more than one data point, right? So instead of saying datum for singular data points, we tend to use the word data because we always have more than one. So you're going to see that word data. Now, statistics. Statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. So what we do is we take a lot of time designing studies, collecting our data, make sure we collect it in a good, ethical way. We'll talk more about good collection techniques as we get through chapters 1 and chapter 2 in particular. And then we'll look at that data and see, what does it tell us? So we let the data tell us what's going on in the world and use that to make decisions. There are two types of data sets we study when we're studying statistics. Those are populations and samples. A population is the collection of all outcomes, responses, measurements, or counts that are of interest. So if you're looking at population data, it means that you have, let's say, surveyed or got data on the entire population. So every single person in that group or every single item, etc. A sample is a subset or a part of a population, and a sample is used to gain information about a population. When we have samples, we do need to make sure that they are representative of the population we're studying. And more often than not, we do use sample data rather than population data. And that's because population data is either often impossible or improbable to get. So what does that mean? So think about if you're doing surveys, right? Even when I do my, let's say, class survey at the end of the semester, right? So most students are used to filling out like a class evaluation on their faculty member. Even then, it's very difficult to get every single student to respond. So let's say I had a class one semester of 25 students, and all 25 students actually responded to that survey, then I would have population data. Usually that doesn't happen though. So usually maybe only 20 students out of the 25 will actually respond. So now I have a sample, I have a subset of the population, and I can use that sample to hopefully get an overall idea of how the class went. With populations, it is usually very, very difficult, if not impossible, to actually get every single, let's say, person's opinion on something, or if I'm looking at maybe items made in a factory, I may not have time to actually look at every single item, for instance. So population data is very difficult to come by. If it's possible to get often it's improbable because it would take too long to get all that data or cost too much money, right? So let's say I'm doing in-person interviews with a certain group of the population. It's not going to be possible for me to fly to every single person's house and interview them across, let's say, the whole country or the whole world, right? It just doesn't make sense. It costs too much money, it takes too much time. So a lot of times we are using samples. And again, we'll talk more about what is a good sample. So you want to make sure your sample reflects the population. So just think about something easy. If I looked at my own class, and let's say I only surveyed the math majors, well, that doesn't really reflect the whole population of my class, right? Not everybody in my class is a math major for statistics. A lot of students at the school take statistics. So that would not be a good sample. Or let's say I only sampled the female students in my class. Again, most classes have both, at least male and female students. So I would just want to survey more people so I'm reflective of that entire class. So just picking out one small group of the class doesn't work. We want to make sure our sample is representative of the whole group. So there's a lot of work that goes into that. And again, we'll talk about that more in chapters 1 and 2. How can you get a good sample so that you're able to actually look at it and get a good idea of what's going on with the population. So the first thing we're going to do here is just look at 2 different examples of how to distinguish between sample data and population data. So here we have a survey, and 834 employees in the United States were asked whether they thought their jobs were highly stressful. Now, as I'm mentioning here, a lot of our examples are based on actual real-world data. So if you go to your text, you'll be able to see the citation there for where this all comes from. I didn't actually copy everything in to our lecture notes, so that's all on your textbook. So just keep in mind that there are citations for most of our examples in class. So 834 employees in the United States were asked whether they thought their jobs were highly stressful. And of the 834, 517 said yes, their job was highly stressful. So our goal here is just to identify what the population is and what the sample is. Now, think about what's going on here. We surveyed and we have 834 employees. Now, obviously the United States is very large and we have many more employees than just 834. So this could not be a population, right? This has to be a subset of that population. So our sample here would be the 834 employees in the US that were surveyed. And what would be our whole population? Well, our population would be all employees in the US, right? So our population would be every single employee in the United States. It's not possible for us to survey every single employee in the United States. It's just too many people. So what we have here is a sample, right? 834 is obviously not everybody. So it's a subset of everybody. So this is our sample. Now, what we can also do is draw a picture here to go along with this. So I'm going to just kind of use the one in your text. And this is a version of a Venn diagram. Usually we're used to seeing Venn diagrams kind of have circles that overlap, but they don't have to be. So this is going to be just a general picture. So let me use a box to kind of represent the entire population. So this would be responses of all employees in the US. So the whole box is our population, if we're just kind of thinking about it visually. And then what happens is, within that group, there's a subset of the people from our survey. So these are the responses of the employees in, running out of room here, the survey. So a subset of that population was surveyed. Now all this other stuff over there, like outside in the box, but outside that little circle, would be the responses of employees not surveyed, okay? So our population is everybody, all employees in the US, right? If we had all of their responses, theoretically. And then the subset is our sample. So these are the people who actually did respond to the survey. And then everybody else would be people who did not respond to the survey. Okay, so we have our overall population and then our subsets, those who responded and those who did not respond. Either because they chose not to respond or likely because they weren't surveyed, right? So we can't survey everybody. All right, here's another example. In a survey of 1,501 9th to 12th graders in the United States, 1,215 said leaders today are more concerned with their own agenda than with achieving the overall goals of the organization they serve. And again, our goal for right now is just to identify the population and the sample. All right, so think about this. We have a survey and 1,501 9th to 12th graders in the United States were surveyed and responded, right? Now, 1,501. This is not every single high school student in the United States, right? Just think about the number. I know my own personal experience. I went to Lowell High School in Massachusetts, and we had over 4,000 students in my high school. So again, this is a sample even within my own high school, right? It's not enough students. So this cannot be everybody. This is a sample. So our sample here would be the 1,501 9th to 12th graders in the US, again, that were surveyed. So what's the population? Think about what the larger group is. So it would be all US high school students. Now, when I say high school, I mean the standard kind of traditional high school of 9th to 12th grade. I know there are some high schools that start at 7th grade or 8th grade, for instance, or maybe 10th grade. So I'm talking the standard high school. So all students are the population, and we just have a survey of about 1,500 of them. Again, if you like pictures, you can think about doing a Venn diagram here. So our overall population would be, again, if we were to get the responses, of all US high school students, right? So again, 9th through 12th grade. And then here my subset would be the responses of US high school students in the survey, right? So here is my overall population, and then here's my specific sample. So those who responded to the survey, and then those who didn't respond are still there. They're part of the population, but they're just not the survey that we're looking for. All right, just making that a little bit clearer for you to see. Okay. All right, now continuing with this idea of population versus sample, we have two more definitions here. So parameter versus statistic. A parameter is a numerical description of a population characteristic. So when you see the word parameter, basically this is data that comes from a population. So it's some sort of calculation. So I shouldn't say just data, but it's usually the calculation that goes with it. So maybe a percent or an average, something like that. Your statistic is a numerical description of a sample characteristic. So again, what's happening is you're using data that comes from a sample. And again, it's some sort of calculation. So maybe an average or a percent or a median. We'll learn all these terms later, but some sort of calculation or observation that you're noticing from sample data. Now you do want to be careful. I used the word statistic already. So we can use that word statistic in two different ways. One, it could be the field of statistics, like we talked about in the first page. So the actual study and the organization and the analysis of looking at this data. So you have the field of statistics, but we also use the word statistic that represents data that comes from samples. So you want to make sure you read carefully when you're reading your notes or you're reading questions to see what they're referring to. So just be careful about that word. Another thing to note is that a sample statistic can vary from sample to sample. However, population parameters should be consistent for the whole population. So what that means is when you have a population, so let's say I actually did have population data, then that parameter, so that average or that mode or that percent or whatever value you calculated would be the same, right, for the whole population. It's just one value for the whole population. Samples change though, depending on the sample data you're given. So if I look at, let's say our population would be all the first year students at our school, right? So if I looked at a sample, I could take different samples. Maybe I take 100 students as one sample, or maybe I take 200 students as a sample. Those could have different averages or different percents because the sample can change. So that's what we're noting here is your samples could have different statistics, meaning averages, percent calculations, modes, medians, whatever we're calculating. Whereas the population is a fixed idea, right? So it's the entire population, it should just be one value. Determine whether each number describes a population parameter or a sample statistic. So does it come from a population or does it come from a sample? So let's read the first one. A survey of several hundred collegiate student athletes in the US found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. So this is the number that we're looking at, this 50 hours per week. So that's an average time spent on athletics. So is this a population parameter or is it a sample statistic? So was this value found from taking a sample of data or from looking at the whole population? Well, notice how it says a survey of several hundred collegiate student athletes. If we're surveying several hundred collegiate student athletes, this is a sample. We're not surveying all student athletes, we're just surveying some student athletes. So this is a sample. That's a sample, then this is a sample statistic. And usually you actually only need the word statistic. We're kind of using that word sample just to drive it home a little bit further. All right, next example. The freshman class at a university has an average SAT math score of 514. Okay. It says the freshman class. It doesn't say some of the freshman class or part of it. It says the freshman class. So what we're looking at here is the entire freshman class or all of the freshman class. So if we have the entire group or all the freshman students, then this is a population. Right? And this makes sense. A lot of schools, when you have to apply, do require SAT scores. So a school would have every SAT score, theoretically speaking, from all its freshman students if they require the SATs, right? So you would have to submit it in order to apply in this case. So that would be everybody. So that's everybody, so it's a population. So this is a population parameter. In a random check of several hundred retail stores, the Food and Drug Administration found that 34% of stores were not storing fish at the proper temperature. So there's our value, and it says a random check of several hundred retail stores. So think about this. Are these all the retail stores or just some of the retail stores? Well, it's just some of the retail stores, right? So this is a sample. So because it's a sample, then this value here is a sample statistic. Last year, a small company spent a total of $5 million $150,694 on employees' salaries. So think about it. Here's our value, right? So we're looking at the total spent on salaries. Now, does this total represent everybody in the company or just some people in the company? Well, it says a small company spent a total of this amount on employee salaries. So again, that small company should have everybody's salary, right? They would know how much everybody's being paid. It doesn't say a sample here or a survey. So everybody is included. So this is everybody or all of the company. So this is a population. So this right here is a population. Parameter. And then one last example. In the US, a survey of a few thousand adults with hearing loss found that 43% have difficulty remembering conversations. So again, a survey of a few thousand adults with hearing loss. Okay. So are these all adults with hearing loss or just some of the adults with hearing loss? It's just some, right? It's a few thousand adults. There's probably more people than that. So this is some, it is a sample. So this percent here, that is a statistic. So if you think about it, if we're looking at all data or the entire group, then you're looking at a population. If you're looking at just some people or just some items, then you have a sample. Okay. So that's the basics between populations versus samples. So again, your population is everything or everybody in a certain group, right? So maybe we're focusing on high school students, or we're focusing on adults in the US, or we're looking at those who are employed. It would be everybody or everything. A sample just includes some people or some things, right? So if I own a manufacturing company or a factory, I may sample some of my items to make sure they're not defective. I may not look at every single item though, right? That may take too long if I'm producing thousands of something a day. So if something is all or entire, the whole group, then that's a population. If it's just some, then you have a sample.